Determinants, applications of determinants and matrices. What is the objective of today's class? We are going to learn about the applications of determinants and matrices for solving the system of linear equations in two or three variables and for checking the consistency of the system of linear equations. So we start with the definitions of consistent system and inconsistent system. When a system is said to be consistent, a system of equations is said to be consistent if its solution exists. That is, if one or more solutions exist, then we say that the given system of equations is said to be consistent. Otherwise, it is inconsistent. That means a system of equations is said to be inconsistent if its solution does not exist. So if the solution does not exist means then we say that the given system of equations is said to be inconsistent, right? Now I move on to solution of system of linear equations using inverse of a matrix. So we are going to solve the given system of linear equations using the concept of inverse of a matrix. Okay. For that, we consider the system of linear equations a1x plus b1y plus c1z equals d1, a2x plus b2y plus c2z equals d2, and a3x plus b3y plus c3z equal to d3. So this is a system of linear equations in three unknowns. What are the three unknowns here? The three unknowns are x, y and z. Okay, these variables are unknown variables here. We are going to find the unknown variables x, y, z, that is our objective. Okay, so we consider the following system of linear equations. Okay, let A equal to matrix A1, B1, C1. What is A1, B1, C1? How will you write this? What are the coefficients of x, y, z from the first equation? A1, B1, C1. Okay, so that is the first row here. And write the coefficients of x, y, z from the second equation. It is A2, B2, C2. That is your second row. Okay. Next, coefficients of x, y, z from the third equation. They are A3, B3, C3. So this is the third row. So what is your A? A is the coefficient matrix. A is nothing but the coefficient matrix. A1, B1, C1, A2, B2, C2, A3, B3, C3. Okay. What is X? X is a column matrix. Okay. Unknown matrix. X, Y, Z. Okay. It's a column matrix. And what is B? B is also a column matrix. It is D1, D2, D3. The right hand side values. Okay. D1, D2 and D3. Now, the above system of linear equations can be written in the form as Ax equal to B. Okay, we are writing the above system of linear equations as Ax equal to B. That is, what is A? A is the coefficient matrix. A1, B1, C1, A2, B2, C2, A3, B3, C3. What is X? X is the column matrix, unknown matrix, x, y, z equals, what is B? B is D1, D2, D3, right? Now consider case 1, if A is a non-singular matrix. So if you consider A is a non-singular matrix, then what will happen? A is a non-singular matrix means then we know that inverse will exist, right? Inverse exists. Non-singular matrix means determinant A is not equal to 0, right? That is the definition. Non-singular matrix means determinant A is not equal to 0. So, I'm going to multiply the matrix equation Ax equal to B by A inverse. How I am going to multiply? Pre-multiplying. Here I am doing pre-multiplying. Okay. Pre-multiplying by A inverse on both sides. Okay. So A inverse of Ax equal to A inverse into B. Okay. So what I am doing here is I have pre-multiplied the above equation by A inverse on both sides. Okay, so A inverse of AX equal to A inverse B. Now group the first two matrices A inverse into A, right? Like this, A inverse into A into X equal to A inverse B. What is A inverse into A? We know that it is an identity matrix, right? A inverse into A is an identity matrix. So I into X equal to A inverse B. So from this, what I am getting is, what is I into X? When you multiply any matrix with an identity matrix, then you will get the same matrix, right? So you will get X equal to A inverse B. So we are solving the above system of linear equations for X. Okay, so what we are getting is X equal to A inverse B, provided A inverse exists. Provided A inverse exists. So this is case 1. What is case 1? If A is a non-singular matrix, then X equal to A inverse B, right? Now case 2. Consider case 2. If A is a singular matrix, in case 1, we have considered that A is a non-singular matrix, whereas in case 2, we are considering that A is a singular matrix. Singular matrix means value of the determinant is 0. Value of the determinant is 0. In this case, inverse will not exist. That we know very well, right? So for a singular matrix, inverse will not exist. So what we have to do, we have to calculate adjoint A into B. We have to calculate adjoint A into B. What is adjoint A? What is the definition of adjoint A? Adjoint A is the transpose of the cofactor matrix. Adjoint A is the transpose of the cofactor matrix. So we have to take the product of adjoint A and B. Okay, when A is a singular matrix. So if A is a singular matrix means, then you have to calculate adjoint A into B. Right. If adjoint A into B is not equal to a zero matrix, if this is not a zero matrix, then solution does not exist. Then solution does not exist. And what is our comment on this? And the system of equations is called inconsistent. If the solution does not exist means, then I will say that the system of equations is inconsistent. Then the system of equations is inconsistent. Okay. If adjoint A into B is equal to zero matrix, if it is a zero matrix, then what will you say? Then system may be either consistent or inconsistent. Then the system of equations may be either consistent or inconsistent. Okay. If it is consistent, then it has many solutions. If it is not consistent, that is inconsistent, means then it has no solution, right? So this is case 2. Now let us see some problems. Look at problem number 1. Solve the system of equations 2x plus 5y equal to 1 and 3x plus 2y equal to 7. So we have two equations in two unknowns. What are the two unknowns? X and y. Okay, here the two unknowns are x and y. So we have to solve the below system of equations, linear equations 2x plus 5y equal to 1 and 3x plus 2y equal to 7. Now let us discuss the solution of this problem. Okay, the above system of linear equations can be written in the matrix form Ax equal to B. Can be written in the matrix form as Ax equal to B. What is A? A is the coefficient matrix that we know. Okay, how will you write A? See the coefficients of x and y in the first equation. What are the coefficients of x and y here? The coefficient of x is 2 and the coefficient of y is 5 from the first equation. So that will be your first row. 2, 5. Okay. What about the second row? Coefficients of x and y from the second equation. So they are 3 and 2. So your second row is 3, 2. Okay. So what is your A? A is the coefficient matrix. It is 2, 5, 3, 2. Okay. What is x? X is the column matrix. Here we have two unknowns, x and y, right? So x, y. And what is B? B is the column matrix. You will write the right hand side values. So 1 and 7, right? So B is matrix 1, 7, column matrix. Now find determinant A. What is determinant A? We are going to calculate it. Okay. So expand the matrix A. In the downward arrow, you'll be getting 4, right? So 4 minus in the upward arrow, you'll be getting 3 into 5, right? 3 into 5. So 4 minus 15. What is 4 minus 15? It is minus 11. Obviously, minus 11 not equal to 0. Therefore, A is a non-singular matrix. A is a non-singular matrix means A inverse will exist, right? A inverse will exist. Non-singular matrix means what is your comment? It has a unique solution. It has a unique solution. So we are going to find the solution. So we have to solve it for x. What is x? X is A inverse B. X is A inverse B. So first we are calculating A inverse and we are verifying that whether inverse will exist or not, right? Okay. Suppose A is a 2 by 2 matrix A, B, C, D, then what is adjoint A? If A is a matrix of order 2, then what is adjoint A? We will interchange the positions A11 and A22, right? Okay, so we will interchange the positions D, A. Then we will change the signs for 1, 2 and 2, 1 positions. 1, 2 and 2, 1 positions. So you will be getting D minus B minus C A. So this is your adjoint A. And what is A inverse? A inverse is 1 by determinant A. So what is determinant A in this case? Determinant A is equal to, in the downward arrow, you will be getting AD. Okay. AD minus, you will have minus in the middle, minus in the upward arrow you will be getting BC. So AD minus BC. Obviously this is not equal to 0 because A, B, C, D are all non-zero. So what is A inverse? A inverse is 1 by determinant A. Determinant A value is AD minus BC into adjoint A. Adjoint A is D minus B minus C A. Okay. So using this concept, I am writing adjoint A directly for the given matrix A. Okay. So adjoint A is 2 minus 5 minus 3, 2. This is my adjoint A. Okay. Next, what is A inverse? A inverse is 1 by determinant A. What is determinant A here? It is minus 11. So minus 1 by 11 and this is your adjoint A. 2 minus 5 minus 3, 2. Right? Therefore, x equal to A inverse B. That is x equal to, this is your A inverse, right? What is A inverse? Minus 1 by 11 and adjoint A is 2 minus 5 minus 3, 2. What is the matrix B? B matrix is column matrix 1, 7. Now we have to take the product of these two matrices. So minus 1 by 11 into first row, first column. So you will be getting 2 into 1, 2. 2 minus 5 into 7 is 35. So 2 minus 35 will be the first element and fix the second row. So minus 3 into 1 minus 3 plus 2 into 7 14, right? So this is your um, 8 to 1, right? So what you are getting on simplification, we are getting 2 minus 35 is minus 33. Okay, minus 3 plus 14 is plus 11, right? So the column matrix minus 33, 11. Now bring this minus 1 by 11 inside the matrix. So you'll be getting minus 33 by minus 11, right? Minus 33 by minus 11 and minus 11 by 11. So on simplification, this is 3, okay? This is 3 and this is minus 1. Therefore, now equating, you will be getting the value of x equal to 3. X equal to 3 and y equal to minus 1. So we have solved it, right? Now look at problem number 2. Solve the system of linear equations by matrix method. What do you mean by matrix method? We have to write the given system of linear equations as Ax equal to B. So this is the matrix method, right? What are the equations given here? 3x minus 2y plus 3z equal to 8, 2x plus y minus z equal to 1, and 4x minus 3y plus 2z equal to 4. So there are three equations in three unknowns. What are the three unknowns here? X, y, and z. So these three are unknowns here, okay? Three equations in three unknowns. Therefore, the above system of linear equations can be written in the matrix form as Ax equal to B. What is A? A is the coefficient matrix. What are the coefficients of x, y, z from the first equation? It is 3, minus 2, 3. Okay. Next, coefficients of x, y, z from the second equation are 2, 1, minus 1. And coefficients of x, y, z from the third equation are 4, minus 3, 2. Okay, so what is your A? A is the matrix 3, minus 2, 3, 2, 1, minus 1, 4, minus 3, 2. Okay, what is X? X is the unknown matrix, column matrix. There are three unknowns given here, X, Y, Z. And what is B? B is the right hand side value. So 8, 1, 4. Okay. Now find determinant A. What is determinant A? It is expanding along the first row. So you'll be getting 3 into 2 minus 3 plus 2 into 4 plus 4 plus 3 into minus 6 minus 4. So on simplification, this is minus 17. Obviously, minus 17 is not equal to 0. Therefore, A is non-singular. Non-singular means inverse will exist, right? Okay, now I'm going to find adjoint A. What is adjoint A? Adjoint A is the transpose of the cofactor matrix. Okay, transpose of the cofactor matrix. So find all the cofactors. Capital A11. Capital A11 is the cofactor of small a11. It is minus 1. Okay. Is not minus 1, it is 7. Okay, so what you are getting is adjoint A is 7 minus 1 minus 1 minus 3 1 0 minus 3 0 1. So this is your adjoint A. Next, find A inverse. A inverse is 1 by determinant A into adjoint A. So 1 by determinant A means minus 1 by 17 into adjoint A. So this is your adjoint A. Okay. Therefore, x equal to A inverse B. Okay, x equal to A inverse B means this is A inverse and this is the B matrix 8, 1, 4. Okay, so take the product of these two. First row, first column. So what you are getting is minus 8, minus 5, minus 4. Okay, that is the first element. Then second row, first column. So minus 64, minus 6, plus 36. Okay, then third row first column, so minus 80 plus 1 plus 28. Okay, now simplify. This is minus 13 minus 4, so minus 17. Okay, what is minus 6 plus 36? It is plus 30. Okay, so plus 30, this is minus 64, so you'll be getting minus 34. Okay, here we have 29 and this is minus 80. Okay, so minus 80 plus 29 is minus 51. Okay, now bring this minus 1 by 17 inside the matrix. So you'll be getting minus 17 by minus 17 gives 1 and minus 34 by minus 17 gives you 2. Minus 51 by minus 17 gives 3. Okay, now equating the values. So you'll be getting x equal to 1, y equal to 2, z equal to 3. Therefore, x equal to 1, y equal to 2 and z equal to 3. Next, problem number 3. Examine the consistency of the system of equations 3x minus y minus 2z equal to 2 and 2y minus z equal to minus 1, 3x minus 4y equal to, sorry, minus 5y equal to 3, right? See the solution. Here we have three equations in three unknowns. What are the three equations? 3x minus y minus 2z equal to 2. 2y minus z equal to minus 1 and 3x minus 5y equal to 3. Okay, now the above system of linear equations can be written in the matrix form as Ax equal to B, where A equal to, what is A? A is the coefficient matrix. So what are the coefficients of x, y, z from the first equation? It is 3 minus 1 minus 2. Okay, next, what are the coefficients of x, y, z from the second equation? Here x is absent, right? There is no x. So coefficient of x is 0. What is the coefficient of y? It is 2. What is the coefficient of z? It is minus 1. Okay, next, what about the third row? What are the coefficients of x, y, z from the third equation? Coefficient of x is 3 and coefficient of y is minus 5. Coefficient of z is 0 because there is no z. Z is not here. It is absent. So coefficient of z is 0. So what is your coefficient matrix A? 3 minus 1 minus 2, 0, 2 minus 1, 3 minus 5, 0. What is x? X is the unknown values column matrix. So x, y, z. What is b? B is the right hand side values 2 minus 1, 3. Okay, now calculate the value of determinant A. Expand along the first row. Okay, so 3 into 0 minus 5 minus 0 plus 3 into 1 plus 4 gives minus 15 plus 15, right? This is actually minus 5. So 3 into minus 5 is minus 15. This is 0. 1 plus 4 is 5. 3 into 5, 15. Minus 15 plus 15 is 0. Therefore, A is a singular matrix. Singular matrix means inverse does not exist. Determinant A is 0. If determinant A is 0 means value of the determinant 0 means then A inverse will not exist, right? Next, find adjoint A. How will you find adjoint A? Adjoint A is the transpose of the cofactor matrix. Okay, so find adjoint A. Adjoint A is minus 5, 10, 5, minus 3, 6, 3, minus 6, 12, 6. Okay. In the previous video, we have explained that how can we find adjoint A, right? So adjoint A is the transpose of the cofactor matrix. We need to find all the cofactors of the elements A11, A12, A13, A21, A22, A23, A31, A32, A33. What is the definition of adjoint A? Adjoint A is the transpose of the cofactor matrix. What is the definition of cofactor? It is denoted by capital Aij. Capital Aij is equal to small minus 1 whole to the power I plus j into the corresponding minor Mij. Okay. Cofactor of small aij is denoted by capital Aij and is defined as minus 1 whole to the power I plus j into Mij. Mij is the corresponding minor. Okay. So here adjoint A is the matrix minus 5, 10, 5, minus 3, 6, 3, minus 6, 12, 6. And this is the given matrix B, 2, minus 1, 3. Now take the product of these two. So minus 5 into 2 minus 10, 10 into minus 1 minus 10, plus 5 into 3, 15, right? First row, first column, over. Next, second row, first column. So minus 6, minus 6, 6 into minus 1 minus 6, plus 3 into 3, 9. Next, third row, first column. So minus 6 into 2, minus 12, minus 1 into 12, minus 12, plus 6 into 3, 18. Okay, so plus 18. On simplification, what we are getting? This is minus 20. Minus 20 plus 15 is minus 5. This is minus 12. Minus 12 plus 9 is minus 3. This is minus 24 plus 18 is minus 6. So what you are getting is the column matrix minus 5, minus 3, minus 6. Here minus is common, so you'll be getting 5, 3, 6. Obviously, this is not equal to a zero matrix. Okay, so if adjoint A into B is not equal to zero matrix, why we are calculating here adjoint A into B? Because we have identified that A is a singular matrix. A is a singular matrix. Here, determinant A is 0, therefore A is a singular matrix. A is a singular matrix means then inverse will not exist. So in this case, we need to calculate adjoint A into B, the product of adjoint A and B. Okay, if the product adjoint A and B is not equal to 0 means then the solution of the given system of equations does not exist. Solution does not exist. So what is our comment? Our comment is the system of equations is inconsistent. Okay, so if adjoint A into B is not equal to zero matrix means then the system of equations is inconsistent. Determinants, applications of determinants and matrices. We see the continuation of applications of determinants and matrices in this video. What is the objective of this class? We will learn some word problems based on solution of system of linear equations using inverse of a matrix. That is, we are going to learn that some statement problems based on solution of system of linear equations using inverse of a matrix. In the last video, we have seen that solution of system of linear equations using inverse of a matrix. So here, what we are doing is we are solving the system of linear equations, that is system of matrix equations using matrix method. So matrix method is nothing but we are using the concept of inverse of a matrix to solve the system of linear equations, right? See problem number 1. The sum of three numbers is 6. If we multiply third number by 3 and add second number to it, we get 11. By adding first and third numbers, we get double of the second number. Represent it algebraically and find the numbers using matrix method. Here, what is given to us? The sum of three numbers is 6. So we don't know those three numbers, right? So what we are assuming is we are assuming that the first number is denoted by x, the second number is denoted by y, and the third number is denoted by z respectively. Let first, second, and third numbers be denoted by x, y, and z respectively. So come to the first statement. The sum of three numbers is 6. How will you represent this mathematically? X plus y plus z, sum of three numbers, addition of three numbers. So we are representing it as x plus y plus z equal to 6. Okay, then we are multiplying the third number by 3. What is the third number here? Z. So we are multiplying z by 3. So we will be getting 3z. And we are adding second number to it. Okay, so what is the second number here? Y. So we are adding the second number to it. So we'll be getting y plus 3z. Okay. So when we are multiplying third number by 3 and adding second number to it, we get 11. So how will you represent that? Y plus 3z equal to 11. Okay. Next, by adding first and third numbers. What is the first number here? X. Third number is z. Okay. So we are adding first and third number. So we'll be getting x plus z. We get double of the second number. What is the second number? Y. So double of the second number means 2y. So how will you write x plus z equal to 2y? So these are the given equations. Okay. So what are the system of equations? X plus y plus z equal to 6, y plus 3z equal to 11, and x plus z equal to 2y. So we have represented it algebraically. Now we are going to solve the system of equations using matrix method. So the above system of equations can be written as Ax equal to b, where A is the coefficient matrix. Okay. So what is A here? 1, 1, 1. How will you write this? The coefficients of x, y, z from the first equation. So it is 1, 1, 1. And the coefficients of x, y, z from the second equation are 0, 1, 3. So that is your second row. What about the third row? Coefficients of x, y, z from the third equation are 1, minus 2, 1. So this will be your third row. So what is the coefficient matrix? A equal to matrix 1, 1, 1, 0, 1, 3, 1, minus 2, 1. What is x? Unknown matrix, right? That is the column matrix. So x, y, z and b equal to right hand side values. We are representing b as a column matrix 6, 11, 0. Now find determinant A. Okay, what is determinant A? Expanding along the first row. So 1 into in the downward arrow you will be getting 1 minus upward arrow. Okay, so it becomes plus 6, right? Then in 1 to position we have the element 1. So for 1 to position we will be getting minus sign, right? So minus 1 into delete the row and the column having the element 1. So you will be getting 0 minus 3 plus in 1 3 position we have the element 1. So when you delete the row and the column having the element 1, you will be getting 0 1 1 minus 2. Okay, so in the downward arrow this is 0 minus upward arrow will be getting 1. Okay, so on simplification we are getting the value 9. 9 is obviously not equal to 0. So determinant A is not equal to 0. Non-zero means A inverse exists. We can find A inverse. So before that I am calculating adjoint A. What is adjoint A? Adjoint A is the transpose of the cofactor matrix. So we have to find all the cofactors. Okay. What is the first cofactor? A11. Cofactor of small a11 is capital A11. Okay. So it is 1 into 1 plus 6. So you are getting 7. What is the cofactor of small a12? It is capital A12. So by definition this is minus 1 whole to the power 1 plus 2. Right? I am finding the cofactor of small a12. So it is capital A12 is equal to minus 1 whole to the power 1 plus 2 into the corresponding minor is m12, right? So this is minus 1 whole cube, minus 1 whole cube. What is m12? We are finding the cofactor of 1. Okay, so delete the row and the column having the element 1. You will be getting 0 minus 3. Okay, 0 minus 3. So it is minus 3. This is minus 3. So what you are getting is minus 3 into minus 1, it is 3. Next cofactor of small a13 is capital A13. It is for this question you will be getting positive sign, so plus 1. Delete the row and the column having the element 1. So you will be getting 0 minus 1. On solving, this is minus 1 into 1, so minus 1. Next, cofactor of small a21 is capital A21. It is for this question you will be getting minus sign, so minus 1 into 1 plus 2, which is minus 3. Next, cofactor of small a22 is capital A22. For this question you will be getting positive sign, so plus 1 into 1 minus 1, 0. Next, cofactor of small a23 is capital A23. For this question, you will be getting minus sign. So, minus 1 into minus 2 minus 1, it is 3. Next, cofactor of small a31 is capital A31. So, this is 1 into 3 minus 1. For this question, we have plus sign. So, plus 1. This is 2. Okay. Cofactor of small a32 is capital A32. For this question, we have minus sign. So, minus 1 into 3 minus 0, it is minus 3. Cofactor of small a33 is capital A33. For this question, we have positive sign. So, 1 into 1 minus 0, it is 1. Therefore, adjoint A is the transpose of the cofactor matrix. So this is A11, A12, A13. So 7, 3 minus 1, minus 3, 0, 3, 2, minus 3. Therefore, A inverse is, what is the formula for finding A inverse? A inverse equal to 1 by determinant A into adjoint A. Okay, 1 by determinant A into adjoint A. What is determinant A? What we have calculated? We have calculated 9. So substitute here 1 by 9 into adjoint A. Adjoint A is 7 minus 3, 2, 3, 0 minus 3 minus 1, 3. Okay. What is the formula for x? We are solving it for x. Okay. So x equal to A inverse B. Okay. Therefore, x equal to, this is your A inverse 1 by determinant A into adjoint A. So 1 by determinant A is 1 by 9. This is adjoint A. So 7 minus 3, 2, 3, 0, minus 3, minus 1, 3, 1. So this is your adjoint matrix, right? And what is BB is 6, 11, 0. Okay. So which implies what is X? X is the column matrix X, Y, Z, which equal to 1 by 9 into, here we need to take the product of these two matrices, right? So first row, first column gives you 7 into 6, 42, minus 3 into 11, minus 33, plus 2 into 0, 0. Okay. Then fix the second row. So 3 into 6, 18, 0 into 11, 0 plus 0, minus 3 into 0, 0, so plus 0. Now fix the last row, third row. So you'll be getting minus 1 into 6, minus 6, plus 3 into 11, 33, plus 1 into 0, 0, right? So on simplification, I am getting 1 by 9 into 9, 18, 27. Now bring this 1 by 9 inside. So you will be getting 9 by 9, 18 by 9, 27 by 9. So on simplification, this is, if you cancel 9 by 9, you'll be getting 1. Then 18 by 9 gives you 2. Then 27 by 9 gives you 3. So on equating, we get x equal to 1, y equal to 2, z equal to 3. Therefore, the three numbers are 1, 2, 3. Okay, you can check this. Sum of three numbers is 6, right? So 1 plus 2 plus 3 equal to 6. You can check with any one of the equation, right? Next, I move on to the next problem. Problem number 2. Problem number 2. The cost of 4 kg onion, 3 kg wheat and 2 kg rice is rupees 60. The cost of 2 kg onion, 4 kg wheat and 6 kg rice is rupees 90. The cost of 6 kg onion, 2 kg wheat and 3 kg rice is 70 rupees. Find cost of each item per kg by matrix method. So what is given in this problem? How to read it carefully. The cost of 4 kg onion and 3 kg wheat and 2 kg rice is rupees 60. So we are discussing three products, right? One is onion, then wheat, next one is rice. Okay, so let us take X denote the number of onions, Y denote the number of Y denote the wheat, okay, and Z denote rice. So here X is not the number of onions, X is onion. X represents onion. The cost of 4 kg onion. So how will you write it as 4x plus 3 kg weight. So you will represent it as 3y plus 2 kg rice. So plus 2z. So 4x plus 3y plus 2z. The total cost is 60 rupees. So 4x plus 3y plus 2z equal to 60. Like that, the cost of 2 kg onion is representing it as 2x. Next 4 kg. 4 kg wheat means plus 4y plus 6 kg rice. So plus 6 is it. The total amount is 90 rupees. Next cost of 6 kg onion and 2 kg wheat. So 6x plus 2y and 3 kg rice plus 3z equal to the total amount is 70 rupees. Okay. So this is the System of linear equations. 4x plus 3y plus 2z equal to 60. 2x plus 4y plus 6z equal to 90. 6x plus 2y plus 3z equal to 70. So we have three equations in three unknowns. What are the three unknowns? X, Y, Z are the three unknowns. So we are going to find cost of each item. Okay. Here there are three items discussed. One is onion, next one is wheat, and the third one is rice. So these three items are discussed here. We are going to find the cost of each item. Okay. Cost of each item per kg using matrix method. So the above system of equations can be written in matrix form as Ax equal to B, where A is the coefficient matrix. So what is your first row? 4, 3, 2. 4, 3, 2 are the coefficients of x, y and z from the first equation. What is the second row? 2, 4, 6. So this is the coefficient of x, y, z from the second equation. What about the third row? 6, 2, 3. So these are the values of x, y, z from the third equation. So what is the coefficient matrix A here? A is the matrix 4, 3, 2, 2, 4, 6, 6, 2, 3. What is X? X is the column matrix X, Y, Z. And what is B? The right hand side value 60, 90, 70. Now I am finding determinant A. We are expanding along the first row. So 4 into, you'll be getting 2 by 2 matrix, 4, 6, 2, 3. So in the downward arrow, this is 12 minus upward arrow 12. Okay, so 4 into 12 minus 12. In 1, 2 portion, we have the element 3. So for this portion, you will be getting minus sign. So minus 3 into, if you delete the row and the column having the element 3, then you will be getting 6 in the downward arrow minus 36 in the upward arrow. Plus 1 3 position we have the element 2. For this position you will be getting positive sign, so plus 2 into 4 minus 24. Okay, so 4 minus 24. On simplification we are getting the value 50, which is not equal to 0. Since determinant A is not equal to 0, A inverse will exist. So we are going to find adjoint A. We know that adjoint A is the transpose of the cofactor matrix. So I am calculating all the cofactors here. Okay, what is capital A11? This is the cofactor of small a11. So for this portion you will be getting positive sign. So plus 1 into 12 minus 12, you are getting 0. Next cofactor of small a12 is capital A12. For this position you have a negative sign. So minus 1 into 6 minus 36. So we are getting the value 30. Next, cofactor of small a13 is capital A13. For this question, you will be getting positive sign. So 1 into 4 minus 24, it is minus 20. Then cofactor of small a21. Okay. In 2-1 portion, we have the element 2. So I am finding the cofactor of 2. Okay. So delete the row and the column having the element 2. In the downward arrow, you will be getting 9 minus. In the upward arrow, you will be getting 4. Okay. For this portion, you will be having minus sign. Because what is the definition? A21 is minus 1 to the power 2 plus 1 into the corresponding minor m21. So this is minus 1 whole to the power 2 plus 1 is 3 into m21. What is m21? We have calculated it is 9 minus 4. So this is minus 1 into 5. So what are getting is minus 5. Next, cofactor of small a22 is capital A22. For this position, we have positive sign. So plus 1 into 12 minus 2. On simplification, we get 0. Next, cofactor of small a23 is capital A23. For this position, we have minus sign. Okay, minus 1 whole to the power 2 plus 3 gives you minus 1 into 8 minus 18. So this is 10. Next, cofactor of small a31 is capital A31. For this position, we have minus 1 whole to the power 3 plus 1. 3 plus 1. So minus 1 whole to the power 4, it is plus 1. So plus 1 into 18 minus 8, it is 10. Next, cofactor of small a32 is capital A32. For this portion, we have minus sign. Minus 1 whole to the power 3 plus 2 into the corresponding minor is M32. What is M32? 24 minus 4, it is minus 20. Similarly, cofactor of small a33 is capital A33. For this question, we have positive sign. So, plus 1 into 16 minus 6. On simplification, we get the value 10. Therefore, adjoint A is the first column is the first row, right? So this is A11, A12, A13. So how will you write? 0, 30, minus 20. The second row is written as second column. So minus 5, 0, 10. What about the third column? 10 minus 20, 10. Okay. Therefore, A inverse is, what is the formula for A inverse? 1 by determinant A into adjoint A. Determinant A already we have calculated. So I am substituting it here. So this is 1 by 50. This is your adjoint A. 0 minus 5, 10. 30, 0 minus 20. Minus 20, 10. Okay. Next, since A inverse exists, we can solve it for x. What is x? X is A inverse into B. So substituting A inverse, this is your A inverse into B. What is the B matrix? It is the column matrix 60, 90, 70. Okay, so which implies what is x? X is x, y, z, the column matrix equal to, we have to take the product of these two, right? Already we have 1 by 50 out. So 1 by 50 into first row, first column gives you 0 into 60 is 0, minus 5 into 90 is minus 450, plus 10 into 70 is 700. Then fix the second row. 30 into 60 gives you 1800. Here we have 0. If you multiply anything with 0, then you will be getting 0. Minus 20 into 70 is minus 1400. Now fix the last row. Minus 20 into 60 is minus 1200. Then plus 10 into 90 is 900. Plus 10 into 70 is 700. Right? So on simplification, we get 1 by 50 into 250, 400, 400. Okay, bring this 1 by 50 inside. So you will be getting 250 by 50, 400 by 50, then again 400 by 50. Okay, so on simplification, we get this is 5. Okay, 5 eights are 40. So this is 8. This is also. So what you are getting is 5, 8, 8. On equating, we get x equal to 5, y equal to 8, z equal to 8. Therefore, the cost of onion is rupees 5 per kg. The cost of wheat is rupees 8 per kg. And the cost of rice is rupees 8 per kg. The next problem is not a word problem. It's a different problem. Here we have to solve the system of equations. Here the system of equations is given in terms of reciprocals. Okay, that is the difference here. The equations are 2 by x plus 3 by y plus 10 by z equal to 4. 4 by x plus 6 by y plus 5 by z equal to 1. And 6 by x plus 9 by y plus 20 by z equal to 2. So what is the difference here? The system of equations are given in terms of reciprocals. So how to solve that? We are going to see. Let us discuss the solution. Since the given system of equations are given in terms of reciprocals, like 1 by x, 1 by y, 1 by z, I am taking 1 by x as p because I don't know how to solve the reciprocal equations, right? But I have learned that how to solve the ordinary equations like x plus y plus z. So I am Considering 1 by x equal to p, 1 by y equal to q, and 1 by z equal to r. I am taking that 1 by x equal to some p, 1 by y equal to some q, and 1 by z equal to r. Therefore, the given system of equations can be rewritten as, okay, already we have 2 here. So actually this is 2 into 1 by x. Am I right? 2 into 1 by x. So this 1 by x can be taken as p now. Therefore, this becomes 2p. And here, this is actually 3 into 1 by y. What is your 1 by y? 1 by y is q. So this becomes 3q. And here we have 10 into 1 by z. 1 by z is r, therefore 10 r equal to 4. Like that, we are representing the other two equations also. So this is not x, this is actually p. So, okay. 4p minus naught minus plus 6q plus 5r equal to 1, then 6p plus 9q plus 20r equal to not 20 minus 20, here also minus 6, right? Therefore the coefficient matrix is A equal to 2 3 10 4 minus 6 5 6 9 minus 20. X is the column matrix x y z, and B is the right hand side values 4 1 2. Now we are calculating determinant A. What is determinant A? We are expanding along the first row. So 2 into, in the downward arrow you will be getting 120 minus upward arrow minus 45. Then for this question you will be having minus sign. So minus 3 into minus 80 minus 30 plus 10 into 36 plus 36. So what you are getting is 1200. Obviously this is not equal to 0. Since determinant A is not equal to 0, A inverse will exist. Now I am calculating adjoint A. Okay. So we have to calculate all the cofactors. What is the cofactor of small a11 here? Capital A11. So this is 1 into 120 minus 45, it is 75. Cofactor of small a12 is capital A12. For this question you will be having minus sign. So minus 1 into minus 80 minus 30, it is plus 110. Cofactor of small a13 is capital A13. For this question we have positive sign. So 36 plus 36, 72. Cofactor of small a21 is capital A21. This is minus 1 into minus 60 minus 90. So 150. Cofactor of small a22 is capital A22. So this is 1 into minus 40 minus 60 minus 100. Cofactor of small a23 is capital A23. So this is minus 1 into 18 minus 18 0. Cofactor of small a31 is capital A31. This is 1 into 15 plus 60, it is 75. Cofactor of small a32 is capital A32. It is minus 1 into 40, 10 minus 40. So it is 30. And cofactor of small a33 is capital A33. It is 1 into minus 12 minus 12, minus 24. Therefore, adjoint A is the first row is the first column. So 75, 110, 72. The second row will be your second column. So it is 150 minus 100, 0. The third row will be your third column. So it is 75, 30 minus 20. Now I am calculating A inverse. It is 1 by determinant A into adjoint A. So 1 by, what is the value of determinant A? 1200. This is your adjoint A. Since A inverse exists, we can solve it for X. What is X? X is A inverse B. This is your A inverse and this is your B matrix. What is B matrix? The column matrix 4, 1, 2. Now take the product of these two matrices. 75 into 4. Plus 300 plus 150 plus 75 to sir 150. Next fix the second row. So 110 into 4 is 440 minus 100 into 1 is minus 100 plus 30 into 2 is plus 60. Then fix the third row. 72 into 4 is 288 plus 0 into 1 0. You multiply anything with 0, then you will get 0 only. Minus 24 into 2 minus 48. Okay. Now bring this 1200 inside. Before that we have to simplify the values. So on simplification I am getting 600, 400, 240. Now bring this 1200, 1 by 1200 inside. So 600 by 1200, then 400 by 1200, 40 by 1200. Okay. Now simplify. Here you will get 1 by 2, 6 by 12 is 1 by 2, and 4 by 12 is 1 by 3, 24 by 12 is 1 by 5. Okay, so 1 by 2, 1 by 3, 1 by 5. On equating, P value is 1 by 2, Q value is 1 by 3, R value is 1 by 5. PQR are 1 by 2, 1 by 3, 1 by 5. But we need X, Y, Z, right? Because the equations are given in terms of X, Y, Z. Okay, what is P? P is 1 by X. Okay, so 1 by X equal to 1 by 2. What is Q? 1 by Y. So 1 by Y equal to 1 by 3. What is R? R is 1 by Z. So 1 by Z equal to 1 by 5. So from this what we can say, 1 by X equal to 1 by 2 means X value is 2. Okay. 1 by Y equal to 1 by 3 means Y value equal to 3. Okay. And 1 by Z equal to 1 by 5 means Z equal to 5. Okay. So this is the required solution. Now I move on to the next problem, problem number 3. If the matrix A equal to 2 minus 3, 5, 3, 2 minus 4, 1, 1 minus 2, find A inverse. Also using A inverse, solve the system of equations. So here the matrix is given to us. The coefficient matrix is given to us. 2 minus 3, 5, 3, 2 minus 4, 1, 1 minus 2. First, we have to calculate A inverse. Then, using that A inverse, we have to find the solutions. Okay, we have to solve it for x, y, z. So these are the given system of equations. 2x minus 3y plus 5z equal to 11. 3x plus 2y minus 4z equal to minus 5. X plus y minus 2z equal to minus 3. We have three equations in three unknowns x, y, z. So what is the given matrix? The given matrix is the coefficient matrix. It is 2 minus 3, 5, 3, 2 minus 4, 1, 1 minus 2. So the above system of equations can be written in matrix form as Ax equal to B, where A is the coefficient matrix. This is given. X is the column matrix X, Y, Z, and B is the column matrix. The right hand side values 11, minus 5, minus 3. Therefore, determinant A is find determinant A. Expand along the first row. So 2 into in the downward arrow we will be getting minus 4 plus 4. It becomes plus 4 plus 3. Already we have in 1 2 question we have minus 3. So we'll be getting positive sign, right? Here when you expanding you'll be getting minus. Already we have minus, so it becomes plus. So plus 3 into, if we delete the row on the column having the element minus 3, then you'll be getting 3 minus 4, 1 minus 2. So in the downward arrow this is minus 6. In the formula you have minus, so it becomes plus 4. In 1 3 position we have the element 5. For this position we have the positive sign. So plus 5 into, delete the row on the column having the element 5. So we will be getting 2 by 2 matrix 3 2 1. The downward arrow it is 3 minus upward arrow minus 2. So on simplification we get the value minus 1. This is 0. This is minus 2 into 3 minus 6 plus 5. So minus 1. Obviously this is not equal to 0. Since determinant A is non-zero, A inverse will exist. So we are calculating adjoint A. For that we have to calculate all the cofactors. So the cofactor of small a11 is capital A11. It is 1 into minus 4 plus 4 is 0. Cofactor of small a12 is capital A12. For this question you have the negative sign. So minus 1 into minus 6 plus 4 is plus 2. Cofactor of small a13 is capital A13. It is 1 into 3 minus 2, 1. Cofactor of small a21 is capital A21. For this question we have negative sign. So minus 1 into 6 minus 5 minus 1. Cofactor of small a22 is capital A22. For this question we have the positive sign. So plus 1 into minus 4 minus 5 minus 9. Cofactor of small a to 3 is capital A into 3. And for this question, we have the negative sign. So minus 1 into 2 plus 3 minus 5. Cofactor of small a31 is capital A31. For this question, we have positive sign. So 1 into 12 minus 10. Cofactor of small a32 is capital A32. For this question, we have the negative sign. So minus 1 into minus 8 minus 15, it is 23. Cofactor of small a33 is capital A33. For this question, you have the positive sign. So plus 1 into 4 plus 9, 13. Therefore, adjoint A is the first row is the first column, transpose of the cofactor matrix. Second row is the second column and the third row is the third column. So 0, 2, 1, minus 1, minus 9, minus 5, 2, 23, 13. Therefore, A inverse is 1 by determinant A into adjoint A. This is 1 by determinant A value already we have calculated. It is minus 1. So minus 1 into adjoint A is 0 minus 1 2, 2 minus 9 23, 1 minus 5 13. So we are solving it for x since A inverse x is. What is x? X is A inverse into B. This is your A inverse. And what is the B matrix? Column matrix 11 minus 5 minus 3. So take the product of these two matrices. Fix the first row. Product of first row and first column. 0 into 11, 0. Minus 1 into minus 5 plus 5. 2 into minus 3 minus 6. Now fix the second row. 2 into 11, 22. Minus 9 into minus 5 plus 45. 23 into minus 3 minus 69. Fix the third row. Then 1 into 11 plus 11. Minus 5 into minus 5 plus 25. Plus 13 into minus 3 is minus 39. Okay. So on simplification, we are getting minus 1, minus 2, minus 3. Now bring this minus 1 inside. So you'll be getting plus 1, plus 2, plus 3. Okay, so 1, 2, 3. On equating, we get the values x equal to 1, y equal to 2, z equal to 3. Therefore, x equal to 1, y equal to 2, and z equal to 3. So we have solved it. Thank you.